All right, good morning everyone. So my name is Katie Miller, also known as Code Miller, and today I'm going to be talking about the Elixir programming language and unveiling some of the elements of this magical blend that I think have contributed to it gaining quite a significant following in a relatively short period of time. So my day job is working for Red Hat as an OpenShift developer advocate. So the OpenShift Pass is not the focus of today's presentation, but I do have some USB bottle openers to help you enjoy your own elixirs later on. So I'm going to be looking for a little bit of audience participation for those. So I want to state up front that I am not an Elixir wizard. I'm not the creator of the language. I'm not one of the core committers. My interest in Elixir came about when I heard a comment from Pragmatic Programmer Dave Thomas, who's written a book about the language, saying that he thinks it's a way to communicate functional programming concepts without academic trappings. Sometimes functional programming is pitched as something that's just for ivory tower types, which I think is complete nonsense. As someone who's an FP enthusiast and also involved in some educational initiatives, so I was interested to see if Elixir might be a good tool to help combat some of those negative perceptions and communicate those FP concepts. Another reason I was interested in it is just because it's a new programming language, and I think looking at the design elements that end up in new programming languages gives us some idea of what's in vogue today. As we'll see, a lot of these ideas are actually very old ones. There's nothing that's really truly new, but I think some of these ideas are becoming more relevant perhaps in the modern computing landscape. So today I am going to give a bit of an overview of Elixir, but it's not going to be a comprehensive introduction to that language or Erlang or OTP or even functional programming itself. Instead, I'm just going to cherry pick and focus on a few key design elements which I think have helped the language to capture attention and imagination. So it's not going to be comprehensive, just my views. So there's not going to be any more dodgy magic terms, but there is going to be code and what is probably an unfamiliar syntax for most people. So gear up your brain for that. So, not progressing. Okay, excuse me. Let's try over here. Excellent. All right, so to start off, I'm going to give a bit of an overview of the language itself. And as a former journalist, I'm going to do that with the good old 5 W's and the H. So to start out, firstly, what is Elixir? So Elixir is a general purpose, dynamically typed language that targets the battle-tested Erlang virtual machine, also known as Beam. So Elixir programs compile down to Erlang bytecode, so there's no performance hit from calling Erlang from Elixir or vice versa. It's clearly, obviously, been influenced by Erlang, both in terms of the virtual machine and the semantics of the language, but there's also a strong influence from Ruby, particularly with regards to the syntax, and also Clojure and its implementation of macros and protocols. And in the tradition of both Erlang and Clojure, it has some pretty good support for functional programming techniques. So where can you find it? Not too many places in production just yet, although I do understand there are a few early adopters who are already using it in prod, but the source code is all on GitHub under an Apache license. So Elixir was created by Jose Valim, hope I've said that correctly, who was well known particularly in the Ruby community as a core committer on Rails, and also for his work on the Devise authentication gem. But these days, there's about 130 people who've contributed to Elixir on GitHub with about 6,100 commits, and it's been forked about 270 times. Elixir is still a very young programming language. Work started on it just 3 years ago, and it was only in August 2012 when the first version came out with equivalent functionality to Erlang, so you could do everything in Elixir that you can do in Erlang. The latest version, which is 0.12.1, was released just a few days ago, so work is still active and ongoing. There's still a few more things to go before a 1.0 will be released, as I understand it, and that is waiting on Erlang 17 being released, so maybe still a little way off, but I think it's getting quite close to that stage. So what's the point of all this? Is this just Erlang with a different syntax? I think the answer to that is a definitive no. People do complain about Erlang syntax, yes, and Elixir does bring a new syntax to the table, but it also brings a whole lot of new features as well. So the philosophy of the language, according to the language's creator at least, is to boost the productivity of developers and also the extensibility of code on the Erlang VM, and it does that via the protocols that it implements, while maintaining compatibility with Erlang and all of the power that brings to build concurrent, distributed, fault-tolerant programs with hot code loading. Elixir has attracted a few fans, and among them, or someone who said quite a few positive things, is Joe Armstrong, the creator of Erlang. So one of the positive things he said Elixir has a non-scary syntax and it combines the good features of Ruby and Erlang. Erlang, as we know, is crucial to parts of half the world's mobile phone networks. And he says it's going to be great fun to see what will happen when this technology becomes less scary and the next wave of enthusiasts joins the party. So I think Elixir is also about accessibility and making the prospect of writing functional style concurrent programs more palatable to more developers. So how does Elixir achieve these goals? Well, there's a lot of different features and I'm not going to have time to go into all of them. So here are what I think are some of the highlights. And there's a few good things in there which aren't in Erlang, including polymorphism via protocols, regular expression literals, UTF-8 encoded strings, and a lot more that, yeah, I don't even have room to list up there. So for a new language, it also has quite a well-developed ecosystem already. Of course, it has everything that Erlang has, so we can leverage all of those libraries, but it also has its own build tool called Mix. There's a unit test framework, a docs tool. There's Ecto, which is like Link for Elixir. It's got a web framework called Dynamo, and there's a repository where you can find good libraries people have written. I think there's about 110 libraries on there at the moment. So that's, yeah, an overview of all the theory. What does this language look like? I'm sure you're dying to know. Show me the code. So here's a bit of a hello world written in Elixir. And as you saw on the previous slide there, everything in Elixir is an expression. So all this code up here could actually be in a single file without any problem. You don't have to have a module necessarily in a separate file. So we've got a module defined there and 3 functions. So we've got this function greet, which takes a parameter called name, but it has a default value of world, and it's returning a tuple. So tuples in Elixir, this is a 2-element tuple, but tuples can be more than 2 elements. We've got an atom called OK, and then a string, which is a binary, as I've already mentioned. So we're doing binary concatenation with these funny angle brackets. And it has string interpolation. So this rate name here brings up another feature. The parentheses around arguments on calls to name functions are optional. So this is calling the rate name function with the name parameter. And as you can see here, you can also define your functions on one line. There's a syntax for that. We're doing size on name, which is actually the number of bytes rather than its length, because strings are binaries, which is a difference from Erlang. So if you have single quoted strings, then it's a list of characters. Otherwise, we're talking about a binary. And this is actually a call to Erlang, this math.py. That's how easy it is to call Erlang library functions. Next function here is doing a little bit of pattern matching. So expecting a tuple, but we don't care what the first element is, so we're not binding it to any name. And then we're just doing a put string to stand it out. And then at the bottom is this pipe, which is something Elixir's become fairly well known for. So this is like a Unix pipe that takes the output for what's on the left and pipes it in as the first argument to what's on the right. So we're calling that hello greet function, which is going to use the default parameter of world, and then sending that to io.inspect, which allows you to print a variable. And then also calling it with value now, code miller, and then printing that out. So it gives you just a quick look at some of the syntax. So that's the whirlwind tour. Now I want to move on and go a little bit deeper with some of its main ingredients. And not everything from the programming language design supermarket made the cut. Objects, for example, I think it got reaction something like this. So Elixir actually kind of actively discourages taking an object-oriented approach in favour of the first major ingredient that has been sprinkled in quite liberally that I want to look at, which is functional programming. So I'm going to show 5 different areas where the language has been designed to embrace the functional programming paradigm. First of all, though, let's have a quick look at where these ideas come from. So functional programming is a style of programming that treats computation as the evaluation of mathematical functions, that is, functions that just map inputs to outputs. Functional programmers tend to avoid mutable data, and they write their programs as lots of small focused functions that are composed or chained together. So programming this style has a lot of implications, which I don't have time to expand on today, but that's FP in a nutshell. One of the big motivations for programming in this style is because it makes it easier to reason about the behaviour of your program, which in turn makes it easier to test, debug, maintain, and also to run things in parallel. Functional programming has its origins in lambda calculus, which is a formal mathematical system developed back in the 1930s by Alonzo Church. So these ideas are certainly not new. So the first functional area I want to look at is immutable data, or data that doesn't change. So all values are immutable in Elixir. So lists, tuples, records, strings, whatever, all immutable. However, unlike in Erlang, it doesn't have single assignment. So in Elixir, you can rebind variables. And you might think immutable data is a fairly inefficient way to go about things, but actually, because nothing is mutable, there are some optimizations that can be made. So parts of structures can be reused where only one part is changed. So let's have a look at an example. So I've got a running example through the talk of calculating standard drinks. So seemed appropriate. So to help with that, I'm defining some records here. So records are just structured data. They're tuples underneath. So we've got a record called liquid, which has a name and an alcohol percentage, which is going to have a default value of 0, and a beverage, which is just going to have content of some liquid and the number of mils of that liquid. And so I can use that to define some liquids there. So we've got now a wine with a percentage of 11.5%, and a glass of it is about 150 mils. And we're going to say that that's the special as well. So with the record syntax, you get a few functions for free. So this house.name allows us to suggest a new name for the record. But if we then go and inspect house later, we'll see that actually the name hasn't changed. And that's because we didn't actually assign the result of doing that to anywhere. So it has made a change, but our original is unchanged because this is the way we work with immutable data. We always return copies of things with the alterations that we want. So if we do actually want to retain that with this house variable, we can assign it. And now we do actually see that change reflected. But of course, if we inspect special, thank you. We'll see that it remains unchanged. So now it's time for you. This is an original concept. It's not just in Elixir. So for a USB stick, where else have we seen immutable data in the programming language world? Clojure. Clojure, yeah, good. List, Haskell. Okay, we've got a few. All right, that's enough for this one. All right. Come up and see me later for the USB stick. So here's a few others where this principle is used. I think it's in most languages. There's something immutable these days, and this is certainly not an exhaustive list. This is just a few. So that's immutable data. The next area I want to look at is pattern matching and guards. So this is used where in a lot of imperative languages you would have different control flow statements. There's an alternative to that. So pattern matching deconstructs structured data. So equals here, it really is an assignment. It's actually a match operator. So here we're saying list, match that to BWS. And when that makes list become the list of BW and S. But if we now say match it to this list of the variables A, B, and C, it's now going to set each of those to the components of that list. So if we inspect B now, it's going to be W. And because Elixir doesn't have single assignment, you can do this again with the same variable names and it'll happily rematch those. So now, doing this now with beer, wine and spirits, B is now set to wine. If you don't want this behaviour and you want the variables when you're matching to retain the value that they currently have, you can add a caret like I have before B here. So now it's trying to match some variable A, wine, some variable C against the list of BWS, and that's not a match, so we get an error. And Elixir will match patterns inside patterns. So this isn't just at a surface level. You can really dig down into your structured data. We also have guard clauses. So if you actually want to match based on your argument content, you can do things like when is number, some variable numDrinks, or numDrinks is greater than 0. But you can't do anything you want in guards. It's only a subset of expressions that are permitted. So to continue on with our example, I've defined a few more drinks. We've now got wine and soda. And now I've created a module with two different implementations of a standard drinks function. But they have different content that they're expecting. So we're matching from the top, so it's going to check and see if our arguments match a tuple that has some beverage and then also a quantity. And you can see that we're matching down a little bit deeper. We also want to match the percentage of alcohol and the number of mils. So we're going right down to get all the little bits that we need. And we've also got a guard clause there. We only care if the percentage of alcohol happens to be greater than 0. And if not, it's going to fall through to the second function definition there. And if something we call this and neither matches, then we're going to get an error. And so on the next line there is just the formula for calculating standard drinks times the quantity. So 0.789, that magic number is just the specific gravity of ethanol. And then we're just putting the output using some magic from Erlang just for formatting it to 1 decimal place. So down here we have our second implementation of standard drinks. This time we don't care about pattern matching anything in the beverage, and we don't really care what the quantity is. I'm just going to say if it's made it to here and it's a valid match, then it's going to have no alcohol. And we can use this so to say, okay, I had 2 glasses of wine, it's going to tell us that's 2.7 standard drinks. I had 5 sodas, well, there's no alcohol in that. So, where else have we seen this? Yes? Mathematica, yeah, definitely. Yeah, in the back?
Prolog and F#.
Okay, yeah, Prolog has unification, but yeah, still, yeah, building on top of that. Yeah, for sure. Okay, and here's a few others. Erlang itself, Haskell, Camel, Scarlet, Rust, another language. So yeah, quite a few places, certainly not limited to Elixir. So the next thing I want to look at is list processing. So this harks right back to one of the oldest programming languages, Lisp, of course, which is named after list processing. And lists have a natural recursive definition. A list can be looked at as either an empty list or an element, consed or constructed on with the tail of the list. So you join the head and the tail, that's your list. And lists defined in that way are sometimes called cons lists or cons-cell lists. And in Elixir, you can match on lists using this pattern. So lists are processed recursively, I mean, as are all the other data structures. There are no loops. So the vertical bar is that list constructor or cons function. And so you can pattern match that way. So you can build a list by saying, so wine consed on to the list of beer and spirits, giving you the list wine, beer and spirits. Unlike some other languages, you can also put 2 things, 2 arguments into cons as well as the tail of the list. So you can also say wine and beer as the first 2 elements consed onto spirits, and that works in Elixir too. And Elixir also has list comprehensions. So more syntactic sugar, if you want to iterate over lists or multiple lists and get cross products, you can do that in Elixir too. And also filter. So here we're getting the cross product of these 2 lists and the multiplication of each of the 2 elements that we get when we do that, but we're limiting it to those results that are less than 30. So we only get 3 results rather than 4. So let's have a look at how this changes our running example. So I've changed beverage to drink instead. So now instead of a single liquid, a number of mils, it's just a list of those. So this allows for things like cocktails. So now standard drinks is just calling this function some standard drinks, which has 2 different implementations. So either a list is an empty list and some accumulator parameter, which we're starting off at 0, or we're matching out the first tuple, drink in its quantity, and then the tail of the list goes into others. And then we're just calling it recursively and adding that accumulator parameter onto what we get when we actually do the calculation, which again, we can do using recursion. So here we've got the quantity. So we're going to calculate the standard drinks for the ingredients in one of those and then send that list of standard drinks and add it all up with some ingredients. And so again, I've got some more recursion to do that. So we've got a list comprehension here to go over the lists and calculate the standard using the same formula as before. and then another recursive wrapper function where we either have an empty list or we're pattern matching on the head and the tail and just adding things up. So it's a little bit verbose, but it shows you the pattern of recursion, which is very common in functional style. And this works. So if we create a few more drinks, so now we've got margarita, beer, and wine, and we say we want to convert 1 wine, 2 beers, and 1 margarita, we get our nice result. That's about 5 standard drinks based on those definitions. So where else have we seen this? Python, yeah, for list comprehensions for sure. Anyone else? Yeah, okay. So yeah, there's a few. So the console list thing, quite a few places. List comprehensions, yeah, even Python has list comprehensions, Ruby, Scala, and whatnot. Next up, lambdas and higher order functions. Bread and butter. It's perfect, isn't it? Of a functional world. So lambdas are just anonymous functions, and there's 2 different ways you can write those in Elixir. So we've got the top line here. So say we want to multiply cost by quantity, so you can use fn, and then we've got the right arrow and end, or you can do the same thing using the partial application syntax. So this is and signed and just saying multiply whatever the first argument is by the second argument. When you call anonymous functions though in Elixir, you do need to include parentheses and the dot. So that's just a quirk of the language, so you call it as shown there. So that's lambdas. A higher order function is any function that takes another function as a parameter or returns one as a result, and it can do both. Prominent examples being map, filter, and fold or reduce. So if we go back to our example now, I've rewritten it to make use of lambdas and higher order functions, and you can see it looks a little more succinct now. So mostly the same logic though. So now we're using these functions from enum. We're doing a map over all the drinks or tuples of a drink and the quantity. So this is the syntax for sending in a named function to a higher order function. So the calc for item function, which has an arity of 1, is all that's meaning. Then pipe the result of that to a reduction, and then that's basically just doing a sum across the list. So we want to multiply the quantity by each of the drinks. How are we going to calculate the drinks? Again, use fold or reduce. So starting off with the accumulator parameter of 0, and using this nice lambda to calculate each individual drink and add the result to our running total, and calculating it the same way as before. And this works. We get the same result. Where else have we seen this? Sorry?
Python battle.
Python, yeah, okay. If you have 1-line lambdas count, then yeah. Perl? Haskell, of course. Haskell's always on the list, isn't it? Even JavaScript, PHP, all over the place. Even Java's almost caught up with this. Almost. Hopefully this year. Okay, and the final feature I want to look at quickly is stream processing. So streams allow you to enumerate a collection lazily. So lazy evaluation. We're delaying the commutation of values until they're really needed. And when we call for them, there they are. So using processing this way means streams that can be infinite, because we're never necessarily going to get to the end of the stream. Some of the functions in Elixir to support this, and this isn't actually part of the runtime, it's just a library thing. They give you functions including cycle, repeatedly, and iterate, which are fairly self-explanatory, unfold, which will be familiar to any of you who are functional programmers, and resource for things like files. So this is almost exactly the same as the previous version, other than the highlighted part. So I've changed it to use a stream instead. Rather than being reduced, now we're doing scan. So what scan does is just give you all the partial results as you do a fold or a reduction. So as you can see from the bottom here, so now rather than sending in a regular collection, we're creating a stream by cycling over the tuples of 1 wine, 1 beer, 1 margarita, and then we're taking the first 5 results from that. And there they are there. You can see the kind of running total as we do the scan across them. Where else have we seen this? Lazy evaluation, streams. ML, yeah, that's a good one. We haven't had that yet. Haskell? Or Haskell? Yeah, so Haskell, obviously lazy language. Generators, I think, perhaps, yeah. Clojure sequences. Again, it's not unique to Elixir. This is good stuff that's kind of well known. So that's the functional features. The next area I want to look at is concurrency and some of the related concepts. So, also having things that are distributed, fault tolerant, the hot code loading. So this again has a long history and has been around for a while in Erlang, definitely. So Elixir leverages the Erlang virtual machine and OTP, which stands for Open Telecom Platform, although barely anyone ever actually says it out. And that was used to make telephone exchanges and switches, which is actually a remarkably good fit for a lot of the requirements that we have in computing today for systems that are highly available and able to deal with inevitable failures. So in these systems, reliability matters. And here again is a quote from Joe Armstrong talking about the famed 9 nines reliability of the Erlang flagship project. And that's basically, blink and you miss it downtime per year, which is very impressive. So OTP brings to the table required components to support that. So it has supervised processes, support for distributed applications, a framework for hot code swapping in quite complex situations, and a way of handling failure. So in OTP, systems are hierarchies of what they call applications, which are made up of processes that follow particular conventions, which they call behaviours. So examples of those behaviours may be a supervisor, it may be an event handler or server, and there are others. So Elixir leverages all of this goodness and uses the actor model of concurrency. So an actor is just an independent process that doesn't share anything with other processes. But you can communicate between them by sending messages to synchronize activities. So Elixir uses the process support in Erlang to achieve this. So these processes are very lightweight. They run across all CPUs with very little overhead. So you can have hundreds of thousands of processes that you spin up on a very modest machine without any trouble. So here's a bit of a look at the syntax for processes. So the arrow here is the send operator, and receive will wait for a message. So what's going on here? We're using spawn to spawn a process and then putting an anonymous function of what it's going to do. So it's going to sit there and wait for a message that matches this pattern of a tuple with a PID and a message, then just send out the message. And doing the spawn is going to give us back the PID of that process that's created. And then using that to spawn another process, which this time is just going to send the message, oh hi, to that process we created. And when you run that, we get, oh hi. So yeah, that's the basic view. Of course, things get a lot more complicated as you move along. And Mix, actually, that's the Elixir build tool, adds some OTP config to new projects by default. So it kind of breaks down some of those barriers to getting started with these things. So let's see if this is going to work. So I've recorded an example of this. Hopefully, here we go. So this is a parallel map function. So it takes a collection, spawn out a bunch of processes in parallel, and then collect up the results. So grabbing that and creating a new version of the standard drinks function called p_standard_drinks, which is going to use the p map instead of the regular map, and also adding a little sleep into the calculation, because otherwise the overhead of the processes is probably going to be more than what's going to be worth it. So now using interactive Elixir, the Elixir REPL, so we've already got some drinks defined there. And so compiling those files, so our p map and also the actual module with the function. And if we are importing that. All right, so now actually using it, so using Erlang's timer capability to say we've got a stream and we want to take 3 margaritas, and it's calculated the result of 4.11 in about 1.8 seconds. Now changing it to use the parallel function instead. And as you can see, it's roughly cut the time by 3, which makes sense given we're calculating 3 things in 3 different processes. And yeah, it's that easy to get started with this stuff. So other appearances for this, Erlang, of course, Scala, and also has extra support in Akka, Go, Rust, and probably many others that neglected to mention. The last ingredient I want to look at is metaprogramming, support for code generation. So macros were inspired by Clojure's macros in Elixir, which in turn were inspired by Lisp macros, which go way back to the 1960s. So again, this is a very old idea. So these are, lost focus again. Here we go. So macros, or in other words, macro instructions offer a way to transform code. And these macros, Lisp-style macros, are syntactic macros. So you also have textual macros, which do more of a naive find and replace kind of thing in the source code. But syntactic macros can actually manipulate the abstract syntax tree. So they're able to preserve the structure of the original program. And the obligatory warning, macros are powerful, but with great power comes great responsibility. If you find yourself using a macro when you could just use a function, you shouldn't be using a macro. But there are some legitimate use cases for them. One in particular that I think is very relevant today is domain-specific languages. Makes it really easy to write DSLs. And in fact, the XUnit test framework in Elixir is written using macros, as are a lot of its other features. So Elixir is what's called a homo-iconic language, just means you can represent it in its own data structures. And then macros allow you to manipulate those data structures. And in the case of Elixir, the representation is generally in the form of tuples. So macros are defined with just the def macro keyword instead of just def, but they have to be defined in their own module. And then the parameters passed to those are in that internal representation form. So then we can use the functions quote and unquote, which anyone familiar with Lisp will already know. So quote takes a block of code and returns its internal representation. When you're within one of those quoted blocks, unquote allows you to inject a code fragment. And macros are hygienic, which just means they won't clobber the variables of things in the local scope where they're called. But you can optionally turn that off if you're crazy. So again, I've got a little demo of how easy this is. So let's say you write fee all the time instead of if. Maybe fat finger syndrome, maybe you've had too many elixirs, whatever. This isn't writing very well. There we go. So there's a macro to actually allow that to be used legitimately. So we've got the quoting here, because what you return from the macro has to be in that internal representation. Then we're just unquoting the things that are passed in. So you can write unless this way or other useful snippets. And I've also defined there, if I can get this to play properly, another version, if inspect, which does exactly the same thing, but actually does an IO and inspect on the things that are passed in, so we can have a look. And so then if we then require this, so this is going to give us an error because you must require macros before you use them. Require and import it. And now we're able to do fee 2 greater than 1, and yep, it works. And if we do it with the if inspect, we actually get to see what that internal representation looks like. So this is what the condition looks like. Makes a fair bit of sense. You've got what operation we're doing, greater than, and the operands, and then also the different clauses of what we actually want to do if that passes. So again, it's very powerful, but actually quite simple to do. This isn't really too difficult. And it's not just in Elixir. Of course, get out of this iFrame. Of course, in Lisp, Scheme, Racket, Clojure, all the Lisp family languages. Scala has some experimental support for macros, and I believe Rust and IO also has some things along this line as well. So what have we learnt from all of this? So we've tasted the Elixir, and I think it's pretty appetizing. It has some great elements, support for functional programming, concurrency, and metaprogramming. And there's also some fantastic benefits of these things. Functional programming helps us to write a more correct code in small, reusable, easy to maintain pieces. Concurrent, distributed, fault-tolerant applications are awesome for today's multi-core, highly available world. And metaprogramming with macros helps us to write DSLs, which can help us to improve productivity and communication. These are all really great features. As we've seen, though, they're not only in Elixir. So this isn't a talk about necessarily go out and you have to use Elixir. These are awesome things that you can use in a whole lot of places as well. There's just one final ingredient that I want to mention, and that's you. It takes people to build a language. You can have the best language in the world. If no one's using it or participating in the community, it's probably not going to go very far. So if you are interested in Elixir or perhaps Rust or even a more established language, I encourage you to get involved because we as a community are responsible for building the programming languages and tools for our community. So if you are keen to get involved, I've got a few resources for Elixir particularly. There's the demo code from this presentation if you want to play with it. Also a whole bunch of Elixir links, and learn use some Erlang down there if you're more interested in Erlang, which is a great resource. Got some image credits. And finally, if you want to find these slides, you can go to elixir.codemiller.com. Thank you very much. Does anyone have any questions? Yes.
I got the new edition of Joe Armstrong's Erlang book, and that has some really exciting R17 stuff.
Mm-hmm.
And not really relevant because I couldn't figure out when to get R17. But does Elixir run on top of that stuff? You know, like all the new WebSocket things, and I think it's got some new instead of just tuples, you've got like native dicks, like maps or whatever.
Yeah, so that's one of the things that the Elixir 1.0 is waiting on. So once R17 comes out, then yes, they're going to be making use of the maps. But oh, sorry. So the question was, no, I summarise that. Just if Elixir is going to build on top of the new capabilities available in Erlang R17, and yes, the answer is yes. Is my understanding anyway. As I said, I'm not one of the developers, so I don't have any inside knowledge of when these things are going to happen. Yes?
What's the performance of Elixir like at this stage?
Sorry, what's the
performance of Elixir like?
I think it's the same as Erlang. I mean, it all compiles down to bytecode, the same bytecode, so yeah, equivalent. And sorry, that question was what is the performance like of Elixir? Anyone else? Okay. Oh, one more.
So what is the motivating factor behind why do we need new programming? I mean, it looks pretty cool, but it's, as you said, nothing particularly new.
That's a very good, so the question is, why do we need a new programming language? I mean, it looks cool, but it's nothing new. Good question. I mean, I'm not an Elixir advocate. I think it's very interesting, and as I said, to note, you know, what features are available. I guess it's combining these things all into one. Rust also has a lot of these features, so you know, maybe it's another one to look at, different horses in the race, but different purposes then as well. But
and you were saying even for the Erlang developer, you were saying there's a lot more people into the fold for functional programming and massive things.
yeah, so that is definitely a motivating factor as well. I guess if, for me anyway, someone is really interested from the FP side, if this can attract more people to FP, then that's excellent. I mean, if Haskell was too scary, then sure, I don't mind if people learn Elixir instead. Oh, well, lots of comments.
It's interesting what's left out.
Yes, yeah, I'd agree with that.
A lot of the features you touched on are all a little bit broken in Go. So it's not surprising that they decided to fix them in another language.
Yeah, my take would be less that Erlang syntax is scary and more that there are just bits of it that, knowing what they know now, that the designers themselves would have done differently, so it's not unreasonable to rebuild a new language.
Yeah, and I think
The underlying LLVM awesome.
and I think that's supported by what Joe Armstrong has said publicly about the language too. If you read his blog, he does have a few critiques of Elixir and things he recommends that they fix up, but in the main, yeah, he's like, woohoo, you know, you fixed a whole bunch of these things that Erlang didn't get quite right.
You mentioned at the start that you involved some educational initiatives. Can you tell us more about anything about that?
Oh, okay. Not specifically with Elixir just yet, but I'm involved in teaching Haskell courses. We're doing one for women in Brisbane probably in the next couple of months. So anyone who's in Brisbane, look out for that. And yeah, I'm involved with teaching teenage girls about the terminal and other such things. Done a few courses with that too. Yes?
You know, are there major projects using Elixir or switching from Erlang to Elixir? And similarly, how easy is it to have a project that uses mostly Erlang but a little bit of Elixir, the libraries?
So yeah, I did try to do some research on who was actually using Elixir, and there were just a few people, I can't remember the names of the projects, but there were people, yeah, who were already using a lot of Erlang and prod who've just kind of started to sprinkle in a few of these features, and I think because it does all compile down to the same bytecode, it is reasonably easy to do that, is my understanding.
One follow-up. Do you know if you have Erlang code, is it easy to call into Elixir? Like obviously you showed it's very easy to call from Elixir to Erlang, but what about the opposite direction?
From what I've read, yes, but I haven't tried it, so I can't really comment on that further.
Is there a Erlang or is it version
Very good question. Not yet. There is an Erlang community cartridge. With Erlang, there's a requirement internally, it's hard-coded to bind to localhost, and that causes a problem on OpenShift. So someone has altered the Erlang source code to get around that. Not obviously a great long-term solution. So. Oh, sorry, the question was, is there an OpenShift cartridge for Erlang or Elixir?
What are kind of zero multiple functional programming languages? What is like your favorite personal functional programming language?
You can't guess. Haskell. It's not perfect, but it comes the closest for me. Okay. So I think that wraps it up, but anyone that helped answer questions, come down. I've got some USB bottle openers. I'll keep handing them out until I run out. Thank you very much.